So for determinants, we have matrix-like expressions, and they write these determinants, like a matrix with some numbers, say A, B, C, and D, but that's different because it doesn't really have this brackets. It is determinant, so they put this in the bars to make sure that you see the difference. So when you don't see the brackets, when you see those bars, it means it's determinant. And it's nothing else but the product across, like diagonal A multiplied by D, subtract the other product across C multiplied by B. For example, if you have 1, 2, 3, 4 numbers here in determinant that compose this determinant, then I'm going to have to multiply 1 by 4 and subtract from it 3 multiplied by 2. One say maybe 2 by 3. Well, it doesn't matter because it's the same thing. So when you subtract 4 and 6, you get a -2. So I just made up an example of determinant. So it turns out that determinants always have a square structure, and they may have various numbers in them when they do this in example 1. And they actually create also a larger size determinants, size 3 by 3. Of course, there could also be 4 by 4. So let me get to the page. I hope it will eventually open. Okay, here it is. So we have this determinant with 3 entries in each of 3 columns. So that's called size 3 by 3. And the way they recommend to deal with these determinants is to convert them to the size 2 by 2. So for example, here we have 2 minus 1, 3, and also -2, and then 5, and then 1, and then 0, 6, and 9. This determinant could be turned into the one size 2 by 2. So what they say is select any of the rows, or actually the columns. So what they did is they selected the first row in this determinant. And when they break this into 3 pieces, notice there are 3 pieces here. The first entry, and then the second entry, and then the third entry, all will be multiplied by those little determinants 2 by 2 that you can calculate the way we just did here. So the way we get those determinants is when we select the first entry of the first column that also belongs to the first row. So it be multiplied by the determinant that is not touched. So it's not first column, not first row. You can see this is A22, A23. You see that? A32, A33. So that's how we start. Then next entry, which is going to be a line in the second column, because it's A in the second column and it's still the first row. The entries that will compose the determinant will be here, 2 of them. They're not in the first and the second, and in the other part. And you can see exactly them here, and here's another part. So we have whatever remains produces that little determinant. And analogously, for the last entry, as you probably already have started to get a better feeling about, I'm gonna use the third entry of my column of my first row. So it'll be third column taken, and whatever is not touched will be producing that last determinant, which is here. Minus Alex, but why is there a minus here? Well, it turns out the signs of entries go from the upper left plus, and then we'll go minus, plus, minus, plus, or if you go down, it's minus, plus, and it's minus, plus. So this has to be plus. So they alternate. You start at the upper left and you alternate. Either you go down with a minus or to the right with minus, and then you go with a plus, either to the right or down. And same here, either down or to the right. So signs alternate, and that's the reason why this is a minus, because it comes with the opposite signed entry. So that's kind of odd. Well, let me work out example 3 determinant, and I like to select the last row in here. So the signs will be plus, minus, plus, minus, and a plus. And for the first entry, which is going to be 0, I will be multiplying it by, since it's in the first column, I'm not going to touch it. I'm just going to use these guys. So it'll be 0 multiplied by something, and that is equal to 0 anyways, because I'll be multiplying by 0, and that's actually why I selected it. So that's why I think it's always convenient to use whenever we have a 0. Let's see, careful. Restore this. So for the next, I'll be using element next to it. Let's see, this is 2, negative 2. Okay. So for the next, I need to use now this third row. So next entry I'm looking at is negative 6. Right? And this be multiplied by another determinant that does not belong to the now it's a second column. Negative 6 is in the second position, and the first row. So what's remaining here? 2 minus 2. That's from my first piece, right? There's 2 minus 2, and there's 3 and 1. Okay, so that's again coming with a minus 6. Well, be careful. Plus, minus, plus, minus. So I have to change the sign here. So instead of minus 6, I must put plus. Do you see that? Plus, because there's a alternation of signs rule here. So it's opposite to what we have. We used to have minus, so it comes with a plus. And finally, the last one will be plus 9. So it'd be coming with a plus, and I need to again multiply it by the little determinant that has only 2 rows and 2 columns that do not have anything from the third column, right? And of course the last row. So it's in this little corner, 2 minus 1 minus 2, 5. 2 minus 2, 5. So this is gonna give me the answer. And that one I don't care for because it's timed by 0. So whatever it is, so what's left will be 6, which is multiplied now by a product of these guys with a plus. So it'll be 2 times 1. And with a minus will be a product of these two, which is negative 2 and 3. So it's always subtracting. So the rule says always subtract these elements. So I had to subtract. And the same thing I'll do in the calculation of the last one, which is here, which is 9 multiplied by, again, there'll be a difference of 2 products, and first one is with plus is main diagonal, people say 2 times 5. And the product of the other diagonal will be subtracted. So it's -2 times -1. So whatever sits there, we don't care. They're just random numbers. So we need to calculate all that. And well, I guess now we're gonna calculate it. So it's 2 plus 6 here, which is gonna be 8. 6 times 8 is 48. And then it's plus what? 10. And there are 3 minuses, right? -1, -2, and subtracting. So it'll be just 2. So 8.
Excuse me, isn't that -6?
Negative and another negative. So that's why I changed sign to positive. 2 minuses. Yeah, plus. But 3 minuses, 1, 2, and 3, it's still a minus. So it just happened that the pair of numbers that we had here, one of them was negative and the other was positive. So I'm looking at that thing, right? Is that correct? It's a +6 here. Oh, you said I put something different. Oh yeah, that's +6. So 6 was here in front, right? Because again, when we tried to work this out, we used this rule of sine. So this was -6, right? So let me double check. That's -6. Oh, now I see where you're saying it, because I put minus, but it's a +6. You're absolutely correct. So you have to be careful with numbers. For some reason, I copied it with a minus. And why did I do that? I can't say for sure. I guess the break was too long, but never know. So anyways, thank you for your correction. So that's a +6 here, not minus, but I have to subtract it. So that'd be actually negative, right? So +6 that I was supposed to change was a minus. Let me do this again so better. Be careful. Negatives, right? This is minus. So you're already better than I at this arithmetic procedures, and that's very impressive. So that'd be 8 and -6, it's -40. I hope now it's better. And then 9, and it's multiplied by 8, it's 72. So it's +72. So you have to add them up and see what the answer is going to be. So it looks like we have something like 24, and let us double check because we have a solution here in the textbook. Because this way I can always try to get it correctly. So in the exercise here, when I subtracted, where is that? Find, actually they don't calculate determinant, they do something else. They find minors. Do they calculate the actual determinant? I don't think so. Well, anyways, I found the determinant, but what they do is something else. They do a little bit different things. So they calculate so-called minors. Say minors, what does that mean? Well, let us calculate minors. Notice that what they do is they just calculate portions of this determinant. What they do is here, they get rid of this first row and the second column. So it's a first row, second column. That's why they call it as minor 1 and 2. And it's a little determinant out of 4 digits, which is right here, -20 and 1 minus 9. Again, you go across, multiply these two with a plus, it's 18, and the other two with a minus, it's -0. So they actually didn't do the whole thing, they just did a part of it. And similarly, they calculated another minor. So that was row number 2. That's why it's 2. It's not 23, it's 2. And then the 3 tells we're in a third column. So our minor was whatever's left over, 2 minus 1, 0, and 6. So that's what they calculate. We say, why is that? Well, because that's used in the next steps. We're doing something a little different. Did they calculate the actual determinant? They didn't. Oh, they actually do it here, right? But they already selected different ones. So they use this little minors. So that's actually what I was trying to do in here. So maybe I can do it again, but with something from the exercise part of section. Because I know it's different story with what you probably ever saw before. So today I just want to calculate some of these determinants. And next time maybe we'll see why we are doing this. So what I'm going to do is open the exercises and well, just do a couple of these calculations and I can actually look at the exercises from 7 through 14 today just to get a good start. So we're gonna need another page to share because not much room here. So. Okay. So let me try, let's say exercise 11, which is a recommended exercise here that has, so we're in the section 11.3. So it's the third section of chapter 11. See, material starts to be different, right? Quite different. And looks like with these tedious arithmetic type of exercises, well, one needs not to hurry. Just carefully write it down and everything be just fine. So 1, 2, minus 2. So I'll do a couple of problems here today. I'm not going to give you a quiz on this, maybe next time when you start to get used to this a little bit better. So what I'll do is I want to calculate it two different ways. So way that they did in the example, they just selected first row and they utilized these minors applied to various columns. So notice that in the first row, we have +3, -4, signs alternate, remember, and +2. So I'm going to utilize these +3, and then -4, and then +2, and multiply them by these little so-called minors, size 2 by 2 little determinants. So let me write them out carefully. So first of all, I'm going to have this first column, right? Excluded. So whatever is left over, -1, 5, and 2 and -2. Now this first column comes back and we go into exclude next column, which is going to be the second column. So that's why -4, the one on the intersection of row and the column, is actually here in front. And whatever is left, 2 1s and 5 -2. 2 1s and 5 -2. Actually, 2 1s like that. I say, what is this all for, Alex? Why do we do this? It's kind of odd and not very intuitive at all. And turns out this is so-called linear algebra, part of this course. And that's completely different story. It's so-called matrices and matrix algebra. That's where we're getting into. And usually students don't see it up to this level. So don't panic. There's a special class called linear algebra, and that's where it's all given with proofs. So they actually do prove that this all makes sense. How about that? So it's quite different class. Whenever you actually take those upper level algebra classes, they're very abstract. And that's why you don't see it intuitively, just dealing with numbers, but then you get proofs and you see, oh, wow, it works. It's just amazing. But here in this class, of course, we don't do any proofs. It'd be too much, turns out. To prove that this is the composition for the determinant takes a while, actually, of special prerequisite stories working with determinants. But anyways, turns out that now I can calculate these little guys and get the actual values, right? So across we get a -1 times -2, and then I have to minus 2 times 5, and this is my first determinant. Now next one is going to be a +1 times -2, subtract 1 times 5, so we'll always subtract. And then the last one here is going to be also a difference of two products. It's 1 times 2 minus -1 times. So we're just using for granted what was actually proved in the next level class, in the linear algebra class. And that's actually what we also do when take statistics. If you ever took statistics, you probably noticed there was a bunch of quite odd looking formulas, but people just utilize them to get nice answers. So anyways, it's a -8 here for the first determinant. Now what do I multiply by -4? Well, this difference of -2 minus 5 is -7. Please double check. So the last one will be 2 times by whatever is in here. It's 2 and 1, which is 3, looks like. Okay, so -24, and that's a 7. 7 times 4 is 28. So there is nothing really special about this. It's a bunch of, again, random numbers, and you get some random result, some other number after you add and subtract. So it's 34 minus 2 is 32. So what I want to do now is to support the fact that it didn't really matter how you calculate this. Remember when I did the previous example, I decided to select not the first, but the last row. So I should get the same exact result. In fact, I have to get exactly the same result, but calculating this a little differently. How about that? I'm gonna be able to utilize this last row. So signs are minus, plus, minus, and plus. So this plus and minus, so just leave it the way it is. And then I'll be able to rewrite this as 1, and then -2, and then another -2, and they be multiplied by whatever is left over. So for the first, I'm going to have left over. Now I should be careful. Now I need to get back my original signs, and that was 3, and the other was -4, looks like, right? -4. Because otherwise, actually it was +4, I think. Let me double check, because otherwise I never get the right answer. It was +4. Okay, 3, 4, 2. Okay, good. So I need that because now I'm putting them in the 2 by 2 determinant. It's 4, 2, -1, and 5. And then for the next one, I'm gonna also have a little 2 by 2 determinant, but let me first of all prepare this. And now we're in the next position in the second row, so I get rid of that second row. So whatever is left over, again, I need to make sure that I have my original determinant without all these pluses, minuses I've been trying to put in. So it's a 3, 1, 1, and then 2 and 5. Okay, 3 and 1. See, it's not -1. I should be careful. It should. So I just copy these. 3, 1, the first column, and the second is 2, 5. And finally, for the last one, I'm gonna go for the last remaining column and also disregard it. Also disregard it. So whatever it is in here, 3, 4, I believe it's +4, and then 1 and negative. And now I should be able to calculate these guys. So that's 4 times 5 minus -1 times 2. Should be careful. This is my first determinant here. Your next determinant is 3 times 5 across, right? And minus 1 times 2, that's my second determinant here. And finally, the third determinant is 3 minus 1. So you need to be, I guess, careful with this. It's not hard, but it is pretty tedious. So what are they? Let's see. I multiply 1 by the result in here, 20, and then it's 1 times 2 is 2, so it's 22. Okay. Minus 2 times, and then I need to get this 15 minus 2, which is 15 minus 2 is 13. Okay. And finally, I have minus 2 left, and I multiply it by minus 3 minus 4 is minus 7, right? Now, let's see if I get 32 or not. 22 is the first one, subtract 26, and then add 14. Okay, so 22. And then 26 minus 14 is going to be 24. So I got 22 here. And minus what? 26 subtract 14 is 12. Plus sign. So I got 34. Oh, I got 34. It's almost there. It should have been also same here. Is that 34? It's 30. Actually, 4, but minus 2, I got 32. Well, it has to be either this or that, or both of them are incorrect. So I guess it'd be a good practice for you to find what determinant actually is equal to, because either way I go, I must have the same answer. So I think I probably miswrote something in one of those guys, and I guess I'm not going to be getting into what I miswrote because it may be a waste of time, but probably for you it'd be good to tell me next time. Is it really 32 or 34? Which one is the answer? Or maybe it's something else. Maybe it's 40, whatever. Okay, so please double check, and maybe what I'll do is try another. I'm not gonna try to tackle it both different ways. I think what confused me maybe that I started to put these pluses, minuses, and that's probably what I made me miss one of these little signs in here. But again, we should be practicing more with that. Practicing. And that's what I'm gonna do before the next time. So I think the key idea is you got the observation that we will just get plenty of room and carefully try to do the calculation. And if I return back here, just wanna maybe give you a little insight into the next step. Instead of doing these calculations of these determinants, I can try number 15 exercise just to show you how they being used to solve systems of equations. Like in exercise number 15, remember we could produce a matrix for this system, and in that matrix we just put coefficients 1 and 1 because it's 1x and 1y, and then 8 on the other side, and then 1 negative 1, and then 4 on the other side. So that's a matrix that we have for the system of equations. And it turns out that we could actually produce various determinants from it. For example, if I just look at the left side, it'd be determinant of this kind, and that will be our, sometimes they call it D1 or main determinant, maybe just like a D without any determinant. It's Greek letter delta, if you ever encountered Greek letter, that's delta. And then they also have the column 8-4 that could be placed instead of either my first column or either instead of second column. So I can have another determinant, say delta 1, if I put that 8-4 instead of first column. So I have 1 and -1 that just stay, but my first column is replaced. And also delta 2, when I put this 8-4, but instead of my second column. So again, in this matrix, I still keep my first column 1-1, and I produce this determinants. And I can calculate them. So again, across 1 times -1, so it'll be -1, and subtract 1 times 1, which is subtract 1, it's -2. And I can also calculate these two determinants the same way. So that's my positive product. It's 8 times -1, it's -8. And what I subtract from it is product of 4 and 1, which is 4. So it's -12. Okay. And finally, for the last one, I have 1 times 4 is 4, subtract 1 times 8 is 8. So that's a negative. So what they say is that I can produce the solution for this system using determinants. And they actually have it here in the formula, so I can support that claim by showing you that you have to divide by that determinant D, both of first and the second determinant you put in numerator, and that's how you find the solutions for the system. Say, Alex, what are you doing? I'm waiting, and here it comes. So the solutions for my little system is here. When I start to divide those two determinants by this determinant D, I need to wait for another page just to show you this nice formula. So I put that D in my denominator. So if I divide the first by my D, and then if I divide the second, that meant to be 2 by D, what I'm gonna get is my solutions. So that's X, not X, X is gonna be produced by divided by the determinant that came out of replacing X with that, which is D1. So what was it? Here's result, -12 and -2, right? So divide -12 by -2. Let me see, how do we know that? Why don't we just solve the system? Well, you can solve the system and double check that. And that's pretty amazing. And then second determinant, which is -4, and I divide it by -2, that will give you y, which is 2. That's actually how the programming goes. So if you ask some type of computer software to solve system of equations, that's how it does it. So it doesn't really start to eliminate anything. They just right away produce determinants and divide things, and that's how this is all being manipulated. So I guess that's why we are looking at this part of story, because it's being used in computer science. And analogously, they also solve systems with 3 equations and 3 unknowns. Remember, we did a couple of those a while ago last week, right? Solving systems. But turns out there are some tools, there is a software, and there are some even graphing calculators like Texas Instruments that solve those systems for you. I'm again waiting for this page to show up. So I'll show you the formulas. If you have X, Y, and Z, that's what I'm talking about. The system with 3 unknowns. So what they do is they just give you this solution with determinants, and they also put this X as dx over d and y, and then there's dz. And the power of this is that for you to solve system 3 by 3 may take a little longer, but they can also solve systems with, say, 10 equations and 10 unknowns. And that will be a task that will take you a few days to do if you use all this eliminations, and sometimes it'd be very messy and difficult to keep track of. But you just enter it in the computer, and it utilizes analogous formulas using determinants and solves it. So I guess that's the point of this, I would say, very tedious section. And turns out there are determinants with 4 entries and 4 unknowns and 10 entries and 10 unknowns. And when I was in graduate school, they were asking us to solve systems with 5 unknowns and 5 equations, and that was really extremely tedious. They had to really write a lot of things, and that's, I think, pointless. But they did lots of arithmetic, all this cross products with pluses, with minuses, and so forth. So next time I plan to show you how to solve this 3 by 3 determinant. Turns out there are various approaches, but it looks like I need to practice myself, right? Because I should have had exactly the same answer, but in both of those solutions. I don't know why I did it both ways. I just wanted to show you that it doesn't matter, but in my case it did, because it doesn't seem to be the same. But there is a little tiny mistake that maybe if you try to discover it by next time, that'd be great, because it'll definitely help you to get used to this. Okay, so I guess I'm going to not give you a quiz today. I'm going to stop the class for today. I know you're still probably in vacation mode after this beautiful long weekend, so you deserve to have a little